Ever puzzled about how the Earth turned into a ball of ice 700 million years ago? This question has left many scratching their heads in bewilderment. After all, it's not every day that you wake up to an ice-covered planet. A mystery of this magnitude warrants a deep dive into our planet's past, and who better to guide us than the stalwarts of scientific exploration? One such explorer is Dr. Adriana Dutkiewicz. A seasoned researcher, Dr. Dutkiewicz was on a mission in the Flinders Hills of Australia when she stumbled upon a curiosity. She noticed that the region's volcanoes were filled with water. This observation sparked a question that would lead her down a path of scientific discovery. You see, 700 million years ago, our Earth was not the warm, life-sustaining planet we know today. Instead, it was a cold, icy sphere, blanketed in frost from pole to pole. Now that's a chilling thought, isn't it? But how did our planet turn into this frigid ball of ice? And more importantly, what caused it to thaw out and become the habitable place it is today? These questions intrigued Dr. Dutkiewicz and her colleague, Professor Dietmar Müller. They decided to investigate this icy mystery, and their curiosity led them to the sediments deposited 60 to 70 million years ago in the Flinders Hills of Australia. Using advanced plate tectonic modeling technology, they hoped to uncover what had caused the Earth's drastic drop in temperature 700 million years ago. Their research, published in the science journal Geology, not only offered insights into Earth's icy past, but also shed light on how our planet's own mechanisms help protect it from overheating. Moreover, it revealed the sensitivity of Earth's climate to the carbon present in the atmosphere. Imagine that the entire Earth is ice. Almost the same thing happened 700 million years ago, says Dr. Dutkiewicz. Ice sheets had formed everywhere from the poles to the equator. But why this happened is a big question. We think we have solved this mystery. Now let's dive into the journey of Dr. Dutkiewicz and her team as they unravel this mystery. The answer lies in the sediments deposited 60 to 70 million years ago in the Flinders Hills of Australia. And so began the research journey of Dr. Adriana Dutkiewicz and Professor Dietmar Müller. Their mission? To unlock the secrets of these ancient sediments and unravel the mystery of Earth's dramatic temperature plunge around 700 million years ago. While many of us might see just a pile of old rocks and dirt, these two scientists saw a time capsule. Each layer of sediment, each grain of soil held clues to what our planet was like millions of years ago. But how to extract this information? Enter the world of plate tectonic modeling technology. This technology, for those of us not in the know, is a bit like a time machine. It allows scientists to rewind and fast-forward the movements of Earth's tectonic plates, the giant jigsaw puzzle pieces that form our planet's crust. By studying how these plates moved and interacted over millions of years, Dr. Dutkiewicz and Professor Müller could make educated guesses about what the Earth's climate was like at different points in history. But it wasn't just about playing with fancy tech. This research required painstaking work examining and testing the sediments to understand their chemical composition, and then feeding this data into their models to create the most accurate picture possible of Earth's past climate. And as they delved deeper into the sediments, they began to see patterns emerge. Changes in the sediments mirrored changes in the tectonic plates, which in turn reflected changes in the Earth's climate. Piece by piece, they started to assemble a clearer picture of what might have caused the Earth to turn into a ball of ice. Their hard work and dedication paid off. The findings from their research were published in the science journal Geology, revealing fascinating insights about our planet. But the journey of discovery doesn't end there. As with any good research, their findings have raised even more questions, sparking further curiosity and paving the way for future explorations into our planet's past. What they discovered was a marvel of Earth's own mechanisms of self-protection. In their quest to unravel the icy mystery of our Earth, Dr. Dutkiewicz and Professor Müller found that the Earth's climate is highly sensitive to the amount of carbon present in the atmosphere. This sensitivity, they discovered, was a key player in the formation of the Ice Age. Historically, there were periods when carbon dioxide emissions were incredibly low. These periods corresponded to times when the Earth was at its coldest, effectively turning into a ball of ice. It was a stark contrast to the common perception that high carbon emissions lead to global warming. Instead, they found that the opposite was also true. Extremely low carbon emissions could plunge the Earth into a deep freeze. But what caused these historically low emissions of carbon dioxide? The answer, it seems, lies in the vast reserves of volcanic rock, particularly those found in what we now call Canada. These reserves played a crucial role in absorbing carbon dioxide from the atmosphere. Imagine the Earth's atmosphere as a giant blanket, with carbon dioxide acting as the threads that keep us warm. Too many threads and we overheat, but remove too many and we freeze. The volcanic rocks acted like a sponge, soaking up the carbon dioxide and thinning our blanket, leading to a massive drop in global temperatures. Dr. Dutkiewicz and Professor Muller also found that the timing of the Sturtian Ice Age was no coincidence. It occurred exactly when carbon dioxide emissions were at their lowest. Furthermore, they found that carbon dioxide emissions remained relatively low throughout the Ice Age. It was as if the Earth had hit a cooling switch and the Ice Age was the result. These findings provide a fascinating insight into the Earth's own protective mechanisms. It shows how our planet, in its own unique way, tries to maintain a balance, a kind of homeostasis. These findings were made possible through the use of the Earthbite computer model. This model, along with the plate tectonic modeling technology, helped the scientists visualize what happened 700 million years ago, leading to a better understanding of the Earth's past, present, and possibly its future. So how did this all come about? Let's delve into the Sturtian glaciation, an intense ice age that swept across our planet around 700 million years ago. This wasn't just a chill in the air. This was a time when ice sheets formed everywhere from the poles to the equator, turning Earth into a giant snowball. This epoch, named after the 19th century explorer Charles Strutt, spanned a whopping 57 million years. Just imagine, a time when there were neither dinosaurs nor trees on Earth. There have been many theories about the beginning and end of this fierce ice age, but the greatest enigma has been how this era persisted for such an extended period. It's a span of time we humans find hard to even fathom. Enter Dr. Adriana Dutkiewicz and her team. Their research, conducted in the Flinders Hills of Australia, has shed light on this age-old mystery. They used innovative plate tectonic modeling technology to simulate the Earth's conditions 700 million years ago. The team's findings suggest that volcanoes played a crucial role in plunging the Earth into this deep freeze. But not in the way you might think. Instead of spewing out heat, these volcanoes were actually contributing to a historically low emission of carbon dioxide. And here's where it gets even more interesting. This period of low carbon dioxide emissions happens to coincide with the existence of vast reserves of volcanic rock in what we now call Canada. These reserves were like giant sponges, soaking up carbon dioxide from the atmosphere. This research helps us understand how one of the Earth's own mechanisms helps protect it from overheating, demonstrating just how sensitive our planet's climate is to atmospheric carbon. So, to sum it all up, the Sturtian Ice Age occurred precisely when carbon dioxide emissions were at their lowest, and these emissions remained comparatively very low throughout the Ice Age. The Earth's deep freeze, it seems, was a complex interplay of geology, climate, and atmospheric chemistry. The Earth's climate is a delicate balance, isn't it? As our journey through the icy past of our planet comes to an end, we are left in awe of the intricate mechanisms that govern our world. Dr. Adriana Dutkiewicz's groundbreaking research has painted a vivid picture of a time when Earth was a ball of ice, a time that seems almost alien to us now. Her findings reveal that carbon dioxide emissions from volcanoes, coupled with the absorption of this gas by silica rocks, played a crucial role in the drastic temperature drop 700 million years ago. This delicate dance of emission and absorption highlights the sensitivity of our planet's climate to atmospheric carbon, a lesson that resonates with the challenges we face today. As we gaze back at the Earth's icy past through the lens of this research, we're reminded of the importance of understanding our planet's history. The Earth's past is a window into its future. By understanding how our planet's climate has changed over time, we can better prepare for what lies ahead.